Hello, pioneers. I'm Dr. M. I'm here to try to take you through the mouse open space behavior graphing tutorial. The idea here is by the time you're done with this tutorial, you'll be able to do the graphs required for this particular lab. Okay, before we get started, you need to have a couple things handy. You need your lab notebook, and you need that opened up to page OSB 7. You need to have tables 2, 4, 5, and 6 from pages OSB 9, 10, and 11 filled out. But if you were having trouble with that, the first part of the tutorial will go through how to do that. You're going to need to have a Windows PC with the latest version of Excel. Now, I'm sorry about this, but I don't have a Mac, so I can't record a version of this tutorial using the Mac software. Excel for Mac and Excel for Windows differ in a couple key points. So some of the things I'm going to go over in the tutorial just won't work on a Mac. And you'd have to Google how to do certain things on the Mac. I'm sorry about that. One good workaround would be to take your Mac over to the library, assuming it's a laptop, plunk down on one of the college computers. You could also do this in a computer lab. You can play back this video on your Mac and actually run Excel on the college's PC. That'd be the easiest way to do it. You need to have the most recent version of Excel. If you have a PC, this is easy. If you have Excel on it already, great. If not, what you want to do is you want to log into office.com, log in with your Marietta College ID as if you were logging in to get email or something. It will bring up a screen you can download and install any of the Microsoft Office apps, and it's free. Okay, so it's just part of the service here at Marietta College. You get free access to the Office apps, so you can download those onto your computer for free. Now, again, that's not going to work on a Chromebook. If you try to use the online version of Excel, there's also going to be some things you can't do. So if you're using a Chromebook, you're kind of in the same situation as with a Mac. You need to go find a PC to do that. Okay, so hopefully you got everything needed. The other thing that I'm going to mention real briefly that you might want is a mouse. Wireless mice are great. You can get them for under 20 bucks, but a wired mouse would work. This lab, it's not too critical to use a mouse, but you'll find in general, particularly in the upcoming yeast respiration lab, trying to do the graphs without a mouse, tracing your finger around on the touchpad is really tough to do. If you've got a touch screen and a pen, yeah, not too bad, but otherwise a mouse just makes things a lot easier. So if you don't have a mouse, you might want to invest in one. But again, not necessary at all for this tutorial. Okay, let's talk about graphs for a minute. Scientists love numbers. Data are good. Okay, scientists love to have a bunch of numbers, but scientists are no better than anybody else at looking at a bunch of numbers and picking out trends or characteristics of the data. Pictures are much better than this, and a picture of the numbers is generally what we call a graph. That's all a graph is. You probably learned about graphs a while back, but let's just do a quick review. And we'll set up a simple, what we might call a Cartesian graph. And this graph has a couple characteristics to it. We have two axes, and the axes are known as the x-axis and the y-axis. And we make an assumption that as you move out to the end of the axis from the origin, as you move in either direction, either out towards here, or if we are talking about moving up towards here on the y-axis, that you're going from a smaller number to a bigger number. But it doesn't always have to be that way. Now, generally, when we set up the axes, we say that the x-axis has the so-called independent data, and the y-axis has the dependent data. Okay, the reason for that is this. Some data, not all, but some data are completely independent of other things. And the best example that I can give you would be time. Okay, if we set up an experiment where we had time on the x-axis and we had, 1 minute, 2 minutes, 3 minutes, 4 minutes, and we set a thermometer out and we recorded a change in temperature, we might get something that looks like that. Okay, and as you can see, as time went on, the temperature generally went up. The temperature depended on time. If this thermometer had been set out in the sun, it would be warming up. Maybe a cloud came through and caused it not to warm up for a minute or so there. But in any event, that was generally what we saw when we did this. The temperature that we got was dependent on how long the thermometer was out in the sun. On the other hand, the reverse isn't true. The time wasn't dependent on what the temperature was. Okay, if you cooled your thermometer down, it would go to a lower temperature, but that doesn't mean you go back in time. If you did that, be a pretty great trick. It'd be probably the excellent hot tub adventure. You would have to be the excellent cold tub adventure in this case if you wanted to go back in time. Okay, but time is generally independent of any other variable. So we almost always put time on the x-axis. Not always, but usually. Other situations, though, X and Y are both independent of each other, or they are both dependent of each other. And that's one of the things sometimes we want to find out. So we plot X against Y and we see if there is a relationship. We see if there's some dependence on them. For instance, for most people, the taller they are, the more they're going to weigh. Those two things are related to each other. And we can't say that one is independent of the other. They both are to some extent are dependent on each other. But that's the way we generally talk about graphs when we're going to do this. Now this type of graph is generally called a line graph, but we want to stay away from that because of the way Excel does things. This would be a scatter plot, okay, where we're pointing specific data points and in this case putting a line in between them to connect them. And that's what we call a scatter plot. Excel has something called a line graph, which is probably what most people would call this, but in Excel, a line graph is very different from a scatter plot, and you almost never want to use a line graph in Excel. So just be aware of that. Okay, so now you might want to look at page OSB 7 and at these two graphs here. Figure 3 there, that looks similar to what we were just looking at. A scatter plot showing the relationship between the region and how much time was spent in that region expressed as a percentage. Okay, figure 2 has the exact same data, but it's displayed as what Excel would call a column chart. Okay, slight difference in terms there between, some people might call that a bar graph, but Excel reserves the word bar graph for when the bars are horizontal rather than vertical. And science doesn't use those a whole lot, so we won't be considering that too much. Okay, so let's take a look at these two graphs. Often the type of graph you choose doesn't really make a whole lot of difference. For instance, percentage data like this can be graphed a number of ways, including the two graphs you see here. It could also be graphed as a pie chart, for instance. When you are considering what type of graph to use, the main thing you want to do is think about the relationship of the data, what you want the viewer to see coming away from this, and how you want to convey that data in a way that doesn't imply something that's not there. And sometimes that eliminates certain types of figures from consideration. And in fact, in this particular lab, of the two figures that you see here, only one of them can be used. It would be absolutely wrong to use the other one in this case. You can do it mathematically, you can do it in Excel. I mean, you can see it right there in front of you, but one of them is wrong, okay? So you want to take a second and look at these and figure out which one is right and which one is wrong. And I'll wait a second for you here. Okay, you got it figured out? We don't want to use figure 3. Okay, that one is wrong in this case. And let me show you why. When you do this type of scatter plot, what you're implying to the viewer is that you have a mathematical model and that the line connecting the dot is where you would expect additional data to fall. Now, the problem is in this particular exercise, we only had 4 things on the X region. We didn't measure if the mouse was halfway between A and B and put a dot on here right about there. We didn't do that. So that line implies data that just aren't in existence. And that's a little bit dishonest. And there's another problem with that if you think about it. What that dot would imply is that 50% of the time, the mouse was huddled right between A and B. It was sitting right on the line between A and B. Now you had rules, you kicked it into either A or B depending on which part of the mouse was where or something like that. But just think about it a little bit further. If the mouse is spending 50% of its time there and it was spending 80% of its time, okay, in square A, then you're already up to 130% without even looking at the rest of the data. And the only person in the world that can get 130% out of anything is a coach, okay? So this just doesn't work. So we are going to have to go with figure 2, and we're going to set up a column chart, okay? And that's where we're going to be turning our attention to next. We're going to take the data and graph it out. Okay, so our next step is to actually get down to work and start on this graph. Again, we decided to use the column chart because this is data that is discrete. Our X category in this case fell into discrete categories. There was no way you could be anywhere in between them. So let's get started. I'm going to enter the data that's found on page OSB 8. Please do that as well so that everybody is doing this first graph exactly the same so you can make sure you got it right. We'll get to graphing your own data later. So the first thing I need to do is put the table in there. And you'll notice I'm in cell B2. I always screw things up, so I don't like to start in A1 because it's a lot harder to add a column or a row above A1 than it is if you've already got a space in there. That's just me though. Maybe you don't ever mess up, so you don't need to do that. So I'm going to put in mouse location, and then I'm going to go over to the next cell, and I'm going to put in the percent of time spent in each square type. Now you may have noticed when I misspelled square. Every time I've done this lab, I've tried to do this tutorial, it's about the 3rd time through, I misspell square. Now you may have noticed I use my arrow key to go from cell B2 to cell C2 because that mouse location kind of overlapped in there, and that could cause you some trouble. So let me show you a real quick fix for this. If you simply highlight the areas that you want to do, and assuming that you are on the home tab up here, okay, then if you just come over to Format, click there, and come down to Auto Fit Column Width, it'll automatically take care of that for you. That's a real time saver. Okay, now the mouse location on page OSB 8, they only give you, they kind of spell 2 of them out for you. But here's another tip for you. Whenever you're doing any kind of scientific communication, whether it's presenting a graph, whether it's getting up and giving a talk, or whether you're writing something out, you kind of want to make the assumption that the person reading it is just about the dimmest person you've ever met, okay? And that includes your instructor who's going to be reading it. You want to make it easy for your instructor. The easier you make it for your instructor to an extent, the better the grade you're going to get. You don't want to leave anything to chance. And one of the things that's really tough for readers is when a scientist who has all kinds of jargon there, just goes ahead and spews it on the page. It makes sense to them, but not to the reader. For instance, you and I all know what squares A, B, C, and D mean. It's crystal clear to us. But to somebody who's never seen that setup, it's not going to be as easy. So let's make it easy for them. Instead of just putting in mouse location A, B, C, and D, we're going to give them names. So A was the wall cells, okay? B was going to be, and if we go back to page OSB 7, it was on that particular, right below that particular graph, they called that the internal squares, which may not be the best. You might want to talk about it with your friends and come up with a better name perhaps. C is going to be the central edge squares. And oops, D is going to be equal to the central squares, okay? Or you could also call it the open center. I think I'll do that. That fits a little bit better with our hypothesis, okay? So that is all the things that we need to set this up, okay? Next step then is to, oops, I'm sorry, we need some actual data, don't we? Okay, so come, oh, look at that. Those things are running over again. So I'm going to highlight the whole B and come over here to Format and Auto Fit Column Width. Okay, no overlap now. Okay, we need our data in here. So 78 and then 15 and 5 and 2. Okay, so now we highlight all of our data and we go to our Insert tab. And on the Insert tab, we come over here to the charts. Now you notice one of them, I just want to point this out, one of them is a line or area chart. You almost never want to do those, okay, in science. There may be times where you do. If you need a chart that has a line on it, you want to come down here and do the scatter plots, okay? And one of the options is to have a line. But we're not doing either of those, remember. We are coming up here and we're going to do a column or bar chart. And what I need to do is click on the little arrow here to make sure I get the right type. You'll notice you have 2D and 3D, and they can be column or bar. Again, in science, we don't do the bar charts very often, and we almost never do the 3D column charts except for the case you see all the way over on the right here. There's a time when you occasionally do those. The problem with the column charts is that it's really difficult to tell where the top is, okay? We know that, for instance, on this one, if you see what's popping up on the screen, you know that one bar is supposed to be at 78, but it's very difficult to read that off that chart. So we're going to stick with the basic 3D column charts all the way up here. Click on that, and our chart is in there, okay? So I'm going to move this now so you can see a little bit better, see our data. And there are a couple things that we need to add to this graph. You notice there's a plus thing over here. If I click on that, I want to have axes. That's good to have. I want to have axes titles there. That's good to have. Now, I personally like grid lines, but some people don't. I'll turn it off for now. Okay, and there is our graph. It needs some fixing up, though. A number of things that need to be fixed up. For one, axis title is not very descriptive. So I'm going to come over here. I'm going to click and highlight that. Sometimes it's a little bit tricky to highlight that vertical thing. And this axis is time, and we call it percent. And again, this is one of the cases where we don't, where we do have time on the y-axis. You don't see that a lot, but this is percent, not actual time, so that makes a difference. I'll come down here, and this area, instead of this is going to be the mouse location, and in parentheses we put square type. Okay, that's the way it's set up in the book. There's other ways you could do that, it would be okay. So that gets our axis titles, okay. We also have to get this title right though, okay? And if you notice the figure on page OSB 8, that gives a good example for how we would title this. We're going to call this figure 1, colon, preference of mice for wall versus open center. Okay, so you put that in there. And a couple things about that. You notice we're calling it figure 1. I want to mention that word figure. In scientific writing, everything that is graphic at all is called a figure. So this would be a figure, a photograph would be a figure, a drawing would be a figure. All those things are called figures. They're not called charts or pictures or anything else. They're called figures. If you have data that is arranged in columns and rows, that is called a table. Okay, and those are the only two things that you would be citing in your paper. And you always put them in order, figure 1, figure 2, figure 3, in the order in which the reader sees them. And that's very important. If you have a figure 1, 2, and 3, and later on you decide you need another figure, and it comes between 1 and 2, then you stick it in there and you have to renumber the rest of them. So it pays to plan ahead on that. Okay, so we have all of our titles in there now, and we want to, there's a couple other things I want to show you just so you can touch them up a little bit. Let's say that we wanted to make this figure 1, we want to make that a little bit bigger. If I highlight it, this little box comes up, and I could change the font here just the way you change it in Word. Okay, you could also, on the home thing here, you could come up in this area and do the same thing. Now, one thing I'll say for Excel, they have some graphic designers working with them that do a pretty good job of making sure when this graph pops up that the rectangle is nicely sized and proportioned and that the text is nicely sized and proportioned. So you may not have to worry about that too much. I wouldn't get carried away with that. If you do need to make any changes in size, what you want to do is you want to make sure that you grab the whole thing, get these handles on the outside, and then you can grab it a little bit, and it will rearrange things. But you want to generally keep it pretty close to the size they gave you. If there is a reason to scrunch it down one way or the other, that's fine. But again, just don't get carried away from it. They gave you a pretty good design to begin with. On the other hand, there's a couple things that also need to be fixed where the graphic designers weren't quite as good. Now, on mine here, for some reason, this bumped up to 100%. Normally, when you do this, when you go into Excel, the maximum won't be 100%. It'll be like 90% like it is there. Okay, so when I moved that, it changed a little bit. We want to fix that. So I'm going to come down here at the bottom of this axis. I'm going to try to click on the axis. And then once I've got it highlighted, I'll right click and I'm going to go to Format Axis. And that is going to bring up a box over here at the side. And I want to come in and where it says Axis Options, the bounds, I want to set the maximum to 100. And this will fix it too. If I rescale, okay, nothing is going to change there. Now there's another important thing that we need to fix on this, and that is the fact that there is no y-axis. For some reason, those graphic designers are so good with the rectangles, forgot that we actually need an axis there. So I'm going to come up here and I'm going to go to the paint bucket, which gives us fill and line. I'm going to go to line and I'm going to make sure that our line is a solid line. And just to be sure, I'm going to make it black. Okay. Now, you can't see it yet because it's still highlighted. I'm going to right click now on my horizontal axis and I'm going to go to it. And again, I'm going to tell it I want a solid line and I want it black. It already figured that out for me. If I click outside here, you can see that I've got my axes are set up well now. Let me scroll over just a little bit so you can see that. And so that's looking pretty good at this point, okay? You can change the inside of the graph a little bit. You can come up here and you can click inside the graph and you can change this plot area. But again, I wouldn't mess around with that. Notice what happened over here. I would, tend not to move things around too much. And once you get it right, just kind of leave it there. Don't do a whole lot. Okay, so let's take this thing to another level here. Let's get a little bit fancier. There's a couple things we could do to fix this up. And I want to point out that what you've got right here, this is what most instructors are going to be happy if you just do what we've got right here. But if you want to get a little bit fancier, remember what I said about making it easier for your reader? If you right-click on your squares, it'll highlight all of them. And you come down here where it says Add Data Labels, and you can come over here, Add Data Labels, and there you are. It puts the actual numbers in there. And that makes it really easy to tell where those things are, even without grid lines. Okay, so that's a nice fancy thing. The other thing is our data here, these are in percentages, okay? So if you look at this, and we're on the Format Data series over here, if I go to the series options, and excuse me, I need to go to the, where's it at here? Format Data series. Oh, I'm sorry, I'm in the wrong spot. There we go. I want to get on the on those actual things right there, the actual get to the label options here. And if I scroll down, one of the things that I'm going to see is number. And if I go to number, I could change the category. I could say percentage. And this is going to really mess things up, okay? Because I've got really big numbers in there, okay? But you can see I've got percentages. While I'm here, we don't need 2 decimal places. We only had one, didn't have 8 decimal places originally. So I'll set that to 0. That makes it a little bit better. But the problem is that we've got numbers in here, 78, 15, 5, and 2. Okay, what we need to do is 0.78, 0.15, 0.05, and 0.02. Okay, and now it looks really weird because those things have almost disappeared. So what I need to do is I need to go on this axis and change the number here as well and change it to percentage, and then also remove those decimal points. And then I need to come back up here to the maximum, and my maximum is not 100 now, it's just 1. And so there we go. Now we've got a nice graph that shows actual percentages there. Again, you didn't need to add the percentages, but if you start down that road, you might want to consider doing it that way. I don't want you, sometimes people get in there and they decide they want to put a percentage in, and they forget they need to change the data, they need to change the decimal points, they need to change the axis itself. Okay, so we're most of the way there. The next thing we need to do is we need to put all this into a document, because you won't be turning in an Excel document, you're going to be turning in a Word document. So what I'm going to do now is I'm going to start up Word, and let's see, there is Word. Okay, we'll start off the blank document. And the first thing you want to do whenever you're going to turn something in is you want to put a bit of a heading on it so your instructor knows what it is. Again, these are not the smartest people in the world, so you need to tell them who you are. You need to maybe give them a hint as to which class they're in. Bio 105, maybe Tuesday, Thursday. And then you might want to tell them what assignment this is, okay? Okay, now that takes up a lot of real estate there, so I'm going to highlight all that. And I'm going to go up here to where it says paragraph, and I'm going to tell it my spacing. I don't want any spacing after, so I'm going to set that to 0. And my line spacing, I want it single. Say, okay. The other thing that you're going to want to do, particularly for your lab reports, is make sure you have page numbers on them. Okay, to put page numbers on, it's really simple. What you want to do is you want to go to insert, and then you want to go to header and footer, and you want to insert a header. And a simple one is you can use this blank 3 columns, okay? And I selected the blank 3 columns, and I go in here and I type maybe my name. So if the instructor drops it and they all get all mixed up, you know what it is. We have mouse graphs or something else like that. And then here I want to put in the page number. And so again, I go to my insert menu and I want to, and this always takes me a while to find because they keep changing it around on me. No, I don't want that in. I just did this yesterday. Let's see. Oh, quick parts. And then I want to go to field. Okay. And under field, if I scroll down, I can get to page. And just 1, 2, 3. Okay. If I want to get real fancy, I could go in front of that and I could have typed in page 1. There we go. Okay. You could even say page 1 of whatever. There's a way to do that. So I come back down to my document, I have to double click, give myself a couple spaces, and I'm ready to start inserting my graphs. Back to Excel. Okay. And let's see, where did my graph go? There it is. Okay. I'm going to click on the graph. I want to make sure I click on the outside of it so I'm getting the whole graph. Okay. And then if I right click, well, my choice is copy. I go back down to Word, into my document, and I'm going to paste. I need to go back to the home menu here. I'm going to paste, but don't just click on that icon. You've got a number of choices here, and I'm going to strongly recommend that you paste this as a picture. If you paste it in some of the other formats, it's linked back to that Excel file. If you change it in the Excel file, it updates in the Word file automatically. And your first thinking is that's great, which it is until you do something like you rename the Excel file or you move it or you delete it. And then Word can't find it and you get a big red X in your lab report, followed by another big red X from your instructor. So you don't want to do that. The way you get around that is you paste it in as a picture, and as long as you can open the Word document, your picture will be there. If I want to move it around, I click on it once. You get this little box here. I'm going to put it the wrapping square so the text will go around it. Position it, and if I move it just right, see that little green line? Tells me it's centered, which is kind of cool. I'm going to click outside it here. I'm going to hit enter a bunch of times so I'm down below it. And now I'm ready to put in my next graph. Okay, let's go back to Excel. Your instructor is going to ask you to put in several different graphs. And I don't know, different instructors are going to want you to graph different things. They might want you to graph your own data and the class data, the first hypothesis versus the second hypothesis, whatever. I don't know what they're going to have you graph, so you're going to need to pay attention. But what I can show you is how to do a second graph very easily and make it identical to the first one. And here's the trick. Notice this is called Sheet 2. Okay, Sheet 2 isn't very good, so I'm going to call this Figure 1 instead. Okay, and then I'm going to right-click on that little tab. Click over here first, come back, right-click on that tab, and I'm going to come up here to where it says Move or Copy. Click on that, and what I want to do is I want to create a copy. Okay, and then I say, okay. And now I have a copy. It says Figure 1, 2. Okay, let's just call this Figure 2. And get rid of that. Yeah, I don't worry about that parentheses. So I come up here, it says Figure 2, and now I'm in a situation where I need to change my data. So let's say we repeated the experiment And the second time around, we did the experiment with the walls removed, okay? And so we got different results. And I'm just gonna go ahead and type my different results in here. I'm gonna keep them, since I've got everything set up with these decimal points, I'm gonna do it the same way. And this time I'm gonna type in, I'm just making up numbers here, 0.048. Whoops, I'm gonna change it to 0.48. Okay, and notice that my that this is updating right away. Okay, and 0.04, 0.03, and 0.42 or 43, whatever. Okay, now one of the things that I want to check, just to double check myself here, I'm going to type in equals and then SUM, sum, parentheses. I'm going to highlight these and then close the parentheses and hit enter. And I'm pretty close. Let me change this one a little bit, and I'm going to change that to 0.05. And okay, I'm up to 100%. So now my graph, when I look at it, it's all been updated, but we have to make two changes. Okay, first of all, this isn't figure 1 anymore. It's figure 2, and it's now preference of the mice for an edge versus open space. Okay, and it's nice to have the title this way because it harkens back to our hypothesis, whatever the hypothesis might be, that mice prefer edges to open spaces. Okay, and the other thing I have to fix is down here. I can't have that A equals wall, so I need to come over, and this is where I change that. A is now equal to, for my computer to catch up, so I'll go up here and do it. A is equal to edge. Updated there. Okay, so I've got figure 2 just the way I want it. Click on the outside of it, right click, copy, go to my Word document, and come down right there, go up to my paste menu, paste this picture, and there it is. Okay, need to center it up. So I do square, and I slide this over. Hopefully I get it lined up right in the middle. There we are, and there we go. Okay, you can crank out graphs left and right this way, and they will be identical to each other, which is one of the things your instructor is going to be looking for. It's hard to make a comparison between two graphs if one of them is bigger or smaller than the other, or it's squished one way or another. You want them as identical as possible. And more importantly, you don't want to give yourself a chance to make more mistakes. So if you get the first graph right and check it very carefully, you can easily make the additional graphs. So all that's left to do is to save this file. And last little hint I'm going to give you for turning in assignments: File, Save As, figure out where it's going to go. I'm going to put it into this documents there. And so I'll just put it in there. And now I need to give it a name. Please don't give it a creative name like mouse graphs or mouse lab graphs or something like that. You're going to have, your instructor's going to get 25 identical files. You want to be professional. You want to give your name, your file name, something that's a little bit more useful. So I'm going to call this McShafery mouse. You don't have to be creative here. Lab graphs. Okay. And then when I save it, I'm going to replace the existing file because I did this yesterday, and there it goes. And I am all done with that. Okay, so took you through how we do the calculations, what type of graphs we do, and how to get those graphs, how to make those graphs, and how to get them into Word. You're all set now to do your assignment. Okay, if you get stuck on some, you can play the video back, you can pause it. There's a number of things you can do. If you have questions, get in touch with your instructor, but I think most of you are going to be good to go. It's really not a very tough assignment. and set you up well for some of the future graphs that we're going to do. They're a little bit more complicated. So this is a good start. So good luck with your graphs. I'll see some of you in lab.